Hello, and in this series we're going to be looking at the Maya camera as far as a settings point of view, looking at the actual settings within the camera and what they mean and how to control the camera. There's a lot of different settings in here, and not all of the defaults are very good, and two, there's some problems that we'll take a look at. And then lastly, what I thought we would do through the series of videos is look at a variety of mental ray lens shaders. You can see that right now I have a camera in the scene which has got a MI exposure simple, which is basically just making sure that the it's basically a tone mapper if you're using 32 bits, saying render to gamma 2.2, because otherwise when we're working in linear color space, we need to be able to preview it in a gamma in the Maya render window that looks correct. So we can set this to 2.2 or 1.8 depending upon what our output device is, or I mean leave it at 1 if we so choose, and then that should be deleted. It doesn't come over through anyways into the if you're rendering out to passes. It will if you are rendering to a single frame still render, and if you're going to be compositing in a linear environment, you're going to want to remove that. So with that said, let's just look at the camera, and the first thing I'm going to do is I'm going to just delete this camera out of here, and we're going to start from a fresh camera. And cameras can be made in a variety of ways, but simply in the most simple way, we can just come up here to create camera, and we're just going to be creating a regular camera because right now we're not concerned with animating it, and we're not making a stereo camera. So I'm just going to click on camera, and like lights, we can just go look through selected camera, and we could begin to position it where we want it. And there we go. Let's see, I think I'm just going to move it back around to here, kind of to where we had it in the same thing. Okay, so now the first thing let's do is let's look at, under the camera settings, let's turn on the film gate. And you can see that the film gate gives us an outline where we can clearly see the outline of what we would imagine would be our render frame, right? So now let's just quickly take a look at resolution gate, and you'll see how it changes. Now this happens to be one of the fundamental things about a camera in Maya, is setting it correctly. And it's something that I notice a lot of people do not do, and is a problem. And oftentimes you won't even know that it's a problem because Maya actually has kind of like a default override that basically says render to the resolution gate, but that doesn't mean that your camera is still set correctly, because it's not. And if you were to have to do some kind of compositing or kind of match your cameras, you would you know, if you wanted to share your camera information, like for instance between Nuke or Houdini or even After Effects, you could run into some real serious issues. Or if you were also doing something like hardware rendering. So the first thing is to let's look at that. So right now I basically have my camera set to a render resolution of 960 by 540, which is basically 16:9. And 16:9 is going to yield us a device aspect ratio of 1.778. And basically what that means is, I mean, we could even let's just turn it on so that you know that I'm correct here, to HD 1080, and you can see that the device aspect ratio did not change. It stayed at, well, it went to 1777, which is something that these things kind of always do. So let's look at a few of these different settings really quick. Like here's CCR 601, which is going to be your DV, and you can see that it went to a device aspect ratio of 1.33 and a pixel aspect ratio of 0.9. Now, just as a side note here, you would never, ever, ever render to that. It would be a mistake to do that. You can, for something like this, which would be a very an older format, which is called standard video resolution, or D1, 720x486, 133, and a 0.9 dot pixel. If you just change that pixel aspect ratio 1 and render to 720x540, you get the same results, and you can squeeze it in post. But let's go back to our HD 1080 and our 16:9 and our 1778, or 1777 in this case. So you can see that this number changes. And what does that number basically mean? Well, that number is defining the aspect ratio of your film back in your camera. So if I come back to this camera, right now we're down all the way in the mental ray node, and I come back and I look at it, I can look down into this film back settings, and I can see that we have what's called a film aspect ratio, and it's set to 1.5 now, and the lens squeeze ratio is 0.1. So now basically these numbers are in conflict, because this is saying we've got a device aspect ratio of 1.77 and a film aspect ratio of 1.5, and the fact that these numbers don't match is actually a problem. So let's just quickly illustrate that, and we'll see how that once it's solved very clearly. So let's look through our camera that we have, which is right now called Camera 1. Let's just come up here to the camera settings and toggle back and forth between the resolution gate and the film gate. And we can see that there's a definite difference. So let's come back up here to this film aspect ratio and set this to 1.77. And you can see that our resolution gate and our film gate are now equal. So if we come back up here and we compare the film gate and the resolution gate, they're now matching. And that's good, because now, for anyone who's ever done this and not had their settings correct, now if we were to come back down here into under environment and create an image plane, we would see that they would match, and that the image plane would exactly match to the camera correctly. So what we're going to do really quick to illustrate this a little bit further is we're going to undo that, and we're going to come back up here and set this camera back to an aspect ratio of 1.55, or 1.5 rather, so that we can see now that if we come back here again, just to illustrate a point, that the film gate is back to that 1.5 and that the resolution gate is set to our 1.77. So we have their conflict. Let's create an image plane. So you can see that the image plane obviously does not match our resolution gate, and it's instead matching our film gate, so that if we come back up here and look at film gate, now the image plane matches, and basically we have a scene that's not set up correctly. It's not going to yield correct results. That if you are trying to do some camera matching, or if you're trying to use a background shader with a still that you've rendered, nothing's going to work out correctly. You're not going to be able to match your focal lengths, and you're not going to be able to share this camera information across any kind of platforms because you don't have the correct settings. So with that said, you now know how to set the correct settings. Let's just go ahead and let's undo that create image plane, so that the image plane is deleted. Let's come back, and we know now that we have to always match our film aspect ratio, in this case to 1.77, or it goes to 1.78, whatever, to our device aspect ratio, in order for us to be able to get secure camera information and to know that we're calculating correctly our angle of view and our focal length for the device aspect ratio, or the film back of the camera. This is a little bit, I'm not going to get technical into this, but it is a little bit technical, and if we look actually here at this camera aperture, what this is describing is this is describing the horizontal and vertical aperture of a film back of our virtual camera. And all cameras have film backs. It's basically, a film back is actually where the film used to sit on the film plane of the camera. Now with a digital camera, it's going to be where the sensor records the information, and the size of the sensor, where it used to be the size of the negative. And this number would change depending upon whether you were shooting a 35mm camera, or let's say a 6.7 camera, or a film camera like an Academy Aperture full app, or whatever it was. And this would tell you how you could match to your real world camera. Now with digital SLRs, and a lot of companies won't give you the information of how many sizes in millimeters our sensor is, we can basically go off resolution. Looking in Adobe Lightroom, I can see that with my Canon D7, for instance, I'm getting a resolution of 5184 by 3456. And while we don't know the size in millimeters of our sensors, we know that this is going to be its output resolution, or its device aspect ratio. So we can plug those numbers into Maya. So if I come back up here to my render settings, Now, I've already plugged those numbers in from Adobe Lightroom just to save some time, and we can see that it yields a device aspect ratio of 1.5. So if I was to come back here, grab all these things in the scene and just quickly kind of hide them, right? With the camera selected and we know our new resolution, we need to come back up here and change our film aspect ratio to the 1.5 of what we're getting with the D7, and I come back down here and I look on image plane and I hit create. The image plane is created, it's matching our resolution gate and it's matching our film gate. And if I come and I set the background image to the same image that I shot, so with the image loaded up in the image plane, we can see that our film back and our device aspect ratio are matching, and that we're not getting any distortion in the image plane, and that we could, if we had to, begin to replicate our camera and do some camera matching to capture the same information as the photograph. So with that said, let's just come back up here and undo all that, because we don't need an image plane. So I'm going to undo all that. I'm going to undo all that so that we no longer have the image plane, and I'm going to come back and I'm going to turn everything on in the scene, and I'll be right back. Now that we're back in Maya and we can see everything in the scene, let's just select our camera and let's come over and let's go over a few of these settings. Okay, well, starting off at the top, we have the angle of view and the focal length, and they're tied together, and the focal length is just basically going to control the angle of view, so you can go from a wide angle effect to a more of like a telephoto type of effect. You can take a look at what that actually looks like by coming up in here into the rendering camera light manipulator, display rendering camera light manipulator, and turning on the clipping planes. We can see those in the top view under wireframe is best. So if you look, you can see now that these green lines appear, and they move in direct relationship to the angle of view or the focal length of your lens. Just to illustrate a point, you can come down here to your clipping planes, and like you could readjust your clipping planes to say, like for instance 10, where you're not even seeing all of your scene, so you can see where the scene is actually clipping off. So we could take a look at that. Like let's put that to 12, and let's come back up here and look through selected, and you can see that our whole scene isn't being rendered at all. We could bump that number up to like a 15, and we got more of it now. Let's just put that back up to like 1,000, and we get all of our scene. We've gone over all the different film back settings, or really actually how to set it to match to your device aspect ratio. We haven't gone over all the different settings. There are some different settings in here that are predefined settings, the old VistaVision 70mm. These are time for another lesson. The one thing that you should be very well aware of here, though, which is a source of frustration for me, is that here under the camera aperture, these numbers, which are moved around in direct relationship to this number, like we've already seen that, right? 1.5 yields different results than those numbers, and we don't really need to play around with these numbers necessarily in Maya. Sometimes you do, but usually it'll be sufficient to put these numbers in. But these numbers are in inches. And when we're translating that camera over into Nuke or Houdini or other 3D applications, most oftentimes they'll ask for the horizontal aperture and the vertical aperture of the camera, and the numbers will be in millimeters, while Maya's are in inches. So you'll simply just have to do an inches to millimeter conversion in order to convert your film aperture correctly if you're going to be putting it into Nuke or Houdini or another application that requires the setting to be in millimeters. So moving on from that, let's just look at a few other settings down here in the Maya camera before we move on to the next step, which is going to be mental ray and lens shaders, and depth of field, which we'll get to in the next setting. You've got output settings here. You can set this camera to be renderable, which means which you want, and there's many different ways of setting that, but you can set it to be renderable right there. If you want to render depth effects and a depth pass into a file, you'll need to put on that you're going to be rendering depth. What type of depth? what type of depth you want to use to count, and this is going to be basically used for how the number is set. Just keep it on furthest visible depth unless you know why you need to change that.